very happy to have Greg from Hedera on stage to introduce us to a new way to do tokenization in a cheaper and more efficient way, hopefully, supposedly. So please come on stage. Very warm welcome. Big applause for Greg.
All good, alles good, thank you. Hello everyone. Yeah, last talk, what a great opportunity as well as a challenge. And I think we've said it before, this stage is amazing, but it's even better with you guys in front of me here. So you should give yourselves a round of applause for being here still on day 2, and particularly on the Saturday. So well done, guys. So I'm Greg, also known as Hedera Kid on social media, wherever you can find me. And today I'll talk to you about hybrid tokens. But before we go into the meat of the subject, I wanted to introduce Hedera to you, just in case you don't know too much about it. It is a network that I'm representing here today. So it's a high-performance, high-throughput network with currently throttled to 10,000 transactions per second per shard, with finality, 100% finality in seconds. It is the most secure. It uses the most secure algorithm for consensus, which implements asynchronous Byzantine fault tolerance. And for those of you who are into consensus algorithms, it is simply the one that makes the least assumptions about the environment in which it operates. And whichever language it's written in doesn't matter. It's the properties of the consensus algorithm that matters. It's not leader-based, so less susceptible to DDoS attacks. Most proof-of-stake networks have a leader at some point, and that's the point of attack, and we're proof-of-stake. In terms of stability, which is very important for us, it's a key property, we believe, for networks to be utilizable or usable by enterprises and institutions. The network will not fork. We have legal and technical guarantees that the network cannot fork. And we also have stable fees in US dollars for transactions. So if you're a startup or an established business, at some point somebody will ask you, how much will your use case cost your organization every year or every quarter? And if you say, depends on the markets, it could be $1,000 a month, $20,000 a month. Somebody will say, no, I need to know a precise number, and that's what I'll give you. So you need stable fees. Market-driven fees do not work. We have a governance, which is also very different to many networks, and I'll talk about that a little bit more later on. And we're a highly sustainable network. We are the least or the most energy efficient network. We're carbon negative, and I'll show you more about that later on as well. So, governance. We have a governing council made of today 29 of some of the largest enterprises in the world across multiple continents, across multiple industries, and they sit on the council for a first term of 3 years, and then they rotate and they're replaced by somebody else in the same category of enterprises. We also have non-profits and universities. So TUM University could one day be one of the council members. Why not? They make all the decisions. One member, one vote, and they decide on everything. They are Hedera. I'm not. I work for them, but they are the Hedera network. In terms of energy efficiency, this is a study by London School, University College London, and they've looked at all of the equivalent proof-of-stake networks, proof-of-work as well, L1 networks in operation today, and have determined Hedera to be by far the most energy efficient. One transaction on the Hedera network, or rather, you could do 1,000 transactions on the Hedera network for the energy cost of one Visa transaction that we do a lot of the time. So leaderless, proof of stake. The consensus algorithm at the bottom is what makes the system work. On top of it, we have some services, a consensus service, or think of it more as a consensus as a service. Through an API, you can submit data to the network. The network will come to consensus on that data. You can encrypt that data. We don't care. You can use it to do all sorts of interesting things. We also have a token service and a smart contract service, which I'll talk about on this particular presentation. So, getting into the meat of the subject now. If you're a blockchain developer today, what is in your toolbox? Most likely, you have smart contracts. And I like smart contracts. They're programmable, they're decentralized. There are things I don't like so much about them. They're slow, they're inefficient, they have high gas costs potentially. So, yeah, if that's what you have in your toolbox, we may consider other things. Have you ever considered, for example, that your tool, the hammer in this case, is not ideally suited to driving screws in wood, your use case? What if there was a tool that made this a lot easier and a lot more practical? Have you ever felt smart contracts are the wrong tool for the job? So the question is, what is in my toolbox working for Hedera? I have smart contracts. They're built on the same EVM as Ethereum. They're a bit faster. They're a bit cheaper to run, quite a lot cheaper. The gas price is fixed in US dollars, for example, so you have predictable fees. But that's not all. I have native tokens, tokens that the Hedera protocol understands natively. I have an API that I can use through all of our SDKs to create a token, mint, burn, blah, 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 all of the features that you may need on a token. And I don't have to write any smart contract code or Solidity to interact with native tokens or even create them on the ledger. Moreover, I can consult all of those properties of a given token on an explorer. I don't have to trust somebody's code to determine whether my token is mintable or has a fixed supply. And more to the point, whenever that's determined or sort of configured when you create your token, it can't be changed. Whereas smart contracts usually are upgradable, even if we say, or rather, even if many people say they're not. They are mutable. So, that's not all I have. I have smart contracts, I have native tokens. Great, those tokens are super fast, super cheap. But what else might I have in my toolbox? I have a Solidity SDK. Oops. I have a Solidity SDK for native tokens. What that means is, in my smart contracts, I can write some code that enables my contract to interact with a native token. So I can mint a token from inside a smart contract. And for the technical amongst us, this is using technology we use we call precompiled contracts. Even if I deploy a native token and I have a DEX deployed on Hedera, which is using a Solidity smart contract, my token looks like an ERC20 contract to that DEX. So the two environments, if we want, are completely ubiquitous from each other. They fully work or interwork with each other. And that creates some interesting capabilities. Specifically, given the toolbox that we've got and these different services, I built a solution called Stablecoin Studio. A Stablecoin Studio, which is open source in our GitHub, is a full example of a hybrid token. It's a stablecoin, as an example. The principle applies to different types of tokens. And in this solution, we have a super fast, super efficient native token for peer-to-peer transfers That's what we want from a stablecoin, right? If you want to buy coffee, you don't want to pay $10, 10 euros of transaction fees, or even one. You would rather pay an awful lot less than that. And I can optionally delegate the management of my native, efficient stablecoin to a smart contract for additional programmability to do things like proof of reserve, conditional minting, enhanced role-based access, and so much more. So what does this look like in terms of architecture? Hybrid token made up of a native token and a smart contract. It's okay to use a smart contract for management. I don't do these operations very frequently. I can pay a little bit more for those. But the peer-to-peer transfers, clearly, I want to have as efficient as possible. Looking at the properties of the 3 different options that we have, on the left, pure native token using an ERC20 on Hedera. The pricing here is the Hedera pricing. The pure native token in the middle, again, the price here is significantly lower. As you can see, the throughput is also much higher. And you can build this using all of the Hedera tools in a toolbox. So the hybrid model on the right-hand side is the combination of the 2, which is in some ways the best of both worlds. So to try and bring a bit of fun at the end of this presentation, to illustrate the difference in terms of costs and throughput between a smart contract, an ERC20 contract on the Hedera network, and a native token. If we look at the Eiffel Tower representing the cost of a transfer through an ERC20 contract, and hello. If the giraffe is a native token, then the giraffe relative to, that should have shrunk slowly. The spot there is the actual size of the giraffe compared to the Eiffel Tower. That's the price of a native token transfer. That's the price of a smart contract transfer. And it's pretty much the same for throughput, except in this case, the Eiffel Tower is the native token, and the other giraffe here is the smart contract, far slower compared to native tokens. That's it. We're done. Happy holidays, happy weekend. I hope this was entertaining. I hope it was insightful, that it may tempt you to investigate Hedera's capabilities. It's broader toolbox. There are other tools that I haven't talked about, the consensus service, file service, and others. You may be able to build things on Hedera that you haven't dreamt of building anywhere else. And if you want to get in touch or look at any of our documentation, it's all up here. Please check it out and get in touch. Thank you.
Awesome. Thank you. Big applause. We do have a couple of minutes, like not extremely many, but again, if 1 or 2 people have a question, put it forward now or not.
AMA time.
So now you can ask where he's living.
I live in France.
Okay, that was a quick answer. Any more meaningful questions than mine? You have one. Awesome.
With the token standard, let's say that you wanted to have a token which had more composability or differences. You didn't just want the standard, like sometimes people want the smart contract style because they can program certain things, maybe not scammy things, like positive things into like logic. Is that still possible? And does the standard allow for that, or would you just write a smart contract at that point?
So the native token is meant to provide 99% of the sort of features that most tokens use today. I mean, if you look at the wide variety of tokens we have on all platforms, they all do pretty much the same thing, give or take a few, outliers, and they're all written using smart contracts. So what we did was to codify what they do on the protocol itself to save the ledger all of this effort and to provide lower price higher speed services, which creates headroom for these outliers that want to use smart contracts for specific use cases. So we're essentially optimizing the use of the ledger where possible, and still enabling the creativity that you can get with for smart contracts. That said, software is not isn't immutable, right? So if there's a good reason for Hedera to improve on the token standard, we have a process whereby the community can provide some suggestions. And then the council that I referred to earlier has a working group called TechCom. They look at all of those. They kind of discuss with the community, and they come to a decision which they put to the council for final vote.
Awesome. Thanks for that. I don't see any other hands. Then, yeah, thanks again.
Cool. Thank you.
Applause for Greg. You're actually the final person to get one, so yeah, enjoy it.
Very special. Prost.
Also refill.